Hi everyone, welcome to Vedantu J English. I am Diksha Kaushal, your chemistry master teacher. So everybody let me know in the chat box if I am clearly visible and audible to you or not. Everybody, so I am very excited for today's lecture because this lecture is not what we do usually. We study the theory, we solve the questions, right? But when someone asks you where you apply this chemistry, some students know, but some students get blank, right? So in our daily life, right, how we apply chemistry, we are going to see that. So everybody let me know in the chat box if you are excited for today's session or not, because I am very excited, right? There are some experiments that we are not experiments, some are basic experiments only, but some are, you can say, DIYs that you can do in the daily life. Okay, so I'll give you the, and one important thing is every single experiment, it is related to class 11th and class 12th. That means the topics that you will study in class 11th and class 12th. And today, one of the best experiments that we are going to do is using a meter, right? So what we are going to do, we are going to see the voltage, right? We are going to see we are going to make a electrochemical cell here, right? So we will make that and we'll see whether we are able to make lemon cell here or not. Lemon cell means from lemon we are going to make the cell. Okay, so all those things we are going to do today. So are you all excited for today's lecture? Right? If yes, then spam the chat box with green hearts and let's start with the first. Let's start with the first experiment that we have. Right? In the first experiment, frankly, I have not done it. Right? Because in the first experiment, right, it is based on that you will have a hot water and you will have cold water. So if you can see that on this table, right, how many jugards I have done, you have no idea, right? This table is books and books and books, and that's how we have this table, right? So everybody let me know if you're able to see these two glasses here, right? Are you able to see these two glasses? So this one is the hot water, right? This one is the cold water, right? This one is the hot water, this one is the cold water. Now, let us see if this is possible. See, because possibility is there, but the problem is that these are the Eno tablets that we have, right? That I just bought from the market. I was expecting some other kind of tablets, but they gave me this kind of tablet. So nowhere I was able to find any tablet which has only calcium carbonate, right? So either though I have to make it myself, you can also eat it, right? So obviously it is for eating, right? So in the ingredients, it is mentioned that it has calcium carbonate, right? And we all know that calcium carbonate, right, that can give carbon dioxide and it can emit effervescence, right? So when you dissolve these tablets in the, we all know that when we have glass of water and you put Eno into it, you have effervescence there, right? That means release of carbon dioxide is there. Now I'm going to put these two tablets in here. Let us see if that happens or not. So the first experiment is hot and cold water and Eno tablet, right? Let us see that this is hot water and this is the cold water, right? I think that is going to take time because you know these tablets, if you see, these are coated with a lot of stuff here, right? I was looking for some tablet that is not coated with a lot of stuff, but this is was coated with a lot of stuff here. So what I need to do is I really need to break it into particles, right? Only then I can get this, right? Because you have a layer outside this, right? That we need to break, right? Only then we can add it into this. Okay, so what I'll do, I'll break the layer that is outside because otherwise the solubility, the dissolution will not be possible, right? Let us see when I break the outer layer, right? Outer layer is just for taste, right? That is for taste, right? So that's why I'm just breaking this outer layer. Now I'll dissolve it if this happens or not. This is the cold water, right? Now, and this is the hot water, right? This is the hot water. So what you can see here, I can see that, I don't know if you're able to see that or not, right? So when you see these two things here in the hot water, still you can see that the carbon dioxide that is there, it is forming bubbles in between. but in cold water, nothing is happening as of now, right? Because the rate of reaction in hot water is more, right? If you can see this here, in hot waters, we can see the bubbles in between. Though it is very less because we are using the tablet version of it, and here you can't see any bubbles. Can you see that here? Here you have no bubbles, nothing at this point, nothing is happening here. But at this point, a lot of things are happening, right, in this hot jar. Can you see this here, everybody? Can you see this here? Right? Can you see this here or not? A lot of bubbles, and here you have no bubbles. That means in cold water, the rate of reaction is very slow as compared to the hot water, right? Isn't it? In the cold water, this is the cold water, nothing is happening, right? Because we are using the tablet. If you use powder, right? If you're using powder form or any other tablet which do not have any coating, right? I'll try to get any tablet which is not having any coating. Right now, though, it was not available in the market, right? So that's why I got this tablet only. But here also you can observe that in this nothing is happening, but in this bubbles are being formed, right? That is visible to everybody, right? If you can see this in the black background, I think that will be more visible to you in the black background, isn't it? So you can see, right, diffusion is more in the hot water, and the rate of reaction is more in the hot water. That we see in the daily life, right? We'll see that in the daily life, that in the hot water, the rate is more as compared to the cold water, right? That's why that happened, right? Okay, so the topic is chemical kinetics, right? Now, why chemical kinetics? Because temperature and rate of reactions, you will study that in chemical kinetics, that as you increase the temperature, the rate of reaction will increase. In fact, it is said that it is experimentally observed that when you increase the temperature by 10 degrees Celsius, let's say if I have a thermometer here, right? If I measure the temperature, if I increase the temperature by 10 degrees Celsius, rate of reaction will get doubled. Okay? Understood? So that was one, it's a starting me random experiment I took. Now, let us see the fishing of the ice. Now, let us see the second experiment, that is the fishing of the ice. For that, I need water, right? So I'll just put water here in the glass jar. I'll put water, right? Can you see water here? Now I'll take some ice and I'll add ice into it, right? Just give me 2 minutes. I'll get the ice because I can't keep ice outside, right? Otherwise the experiment will not happen, right? So just give me 2 minutes. Okay, so now we have ice also, right? And we have thread also, right? And we have mic also, right? So I'll just connect the mic here. And this is water, simple water, right? Now what I'll do, I'll just break the ice. I'll just put the ice in between it, right? I'll just put the ice here, right? You can just directly put the ice or you can just break it, right? Totally your choice how you want to put it, right? Now I think this much ice is only possible here, right? I wanted to have more ice here, but I think the jar is very small, right? Let's see if this is possible in a small jar because before I did it in a big jar, right? Now, what I'll do here, everybody, now what I'll do here, right? Huh. Now I have this thread, right? I'll just pick out this thread here, right? And randomly, I'm going to dip this thread in this jar. Randomly, right? Randomly, I'll just dip this thread in this jar, right? You can just dip this thread in this jar, right? And that's it, right? I think this one is enough, right? Now, if I try to take it out, as you can see, no ice I can pick, right? Again, I'll dip this thread into the jar. Again, I'll dip this thread into the jar, into the jar, into the jar, into the jar, and here I have the thread, right? I can dip more of it also, totally your choice. Now, we will add salt into it. Okay, so this is salt, घर का salt, common salt. You can just sprinkle the salt into it, right? And we can just sprinkle the salt into it, right? This is salt, 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 salt. You can sprinkle more of salt here, right? More of salt I sprinkled here, right? Okay. Now, what you will observe here? Everybody, let us see what you will observe. Can you think what will happen here? I also send you this particular video that after this, what will happen? With the help of thread, I'll be able to pick this ice. After 1 or 2 minutes, let's give it 1 or 2 minutes, right? We could have added more ice into it. We could have added more ice into it. Let's see, because if you have a big jar, okay, you place big ice cubes into it, then definitely this experiment was on. But now we have to wait for it, right? So this experiment, right, is based on depression of freezing point, right? Depression of freezing point you will study in solutions in your class 12th, right? Depression of freezing point means that when you add a non-volatile solute, so salt is a non-volatile, it is not volatile, right? That is the solute. I added it into the water. Now, what will happen? The melting point, the freezing point will decrease here, right? Because the freezing point decreases here, this thread, right, the ice is going to get attached to each other, right? And that is the reason this thread will get stuck in between the ice cubes. Okay, so let us see. The ice will come with the thread. Okay, let us see that. When you will teach electrochemistry, wait for some time. I think 2 minutes, or should we wait for 1 or 2 more minutes? Should we wait? Should we wait? What do you think? Right? Should we wait or not? I think we should wait now. Yes, we are able to pick not all of it, but some of it, right? So when I did it with a like lot of ice, we can also do it with a lot of ice, right? You can add more ice into it, right? So I can add more ice into it. If you add more ice into it, right? I'll just put the water somewhere. Okay. Okay. Chalo. When you add more ice into it, right? Then if you drop the thread, okay? Now again, I'll use some salt here. I think this much ice was needed, right? I added too much of water, right? This much ice was needed because I want to show you the experiment properly, right? Okay. Now I'll add some salt into it, right? I'll just carry some salt here. Okay. So again, we will do the same thing, right? We'll sprinkle some salt into it, right? Okay, so this is the salt that we sprinkled here, right? I'll sprinkle some more salt into it, right? Now I'll see if that is possible or not, right? Okay, just give it some time because these experiments, no, sometimes you add more water, less water. So can you see that ice melt really fast, right? So that is the reason the hold was there. It was able to hold the ice, but it dropped off very quickly. But in the morning when I did the same thing, it was able to hold it for like 1 minute or so because I had more ice and less water, right? Okay. So let us see, let us keep it somewhere, right? Let us keep it somewhere and let's focus on the next experiment. This is based on depression in freezing point that you will study in the solution chapter, right? Okay, next is egg floating in the salty and simple water, right? So now we will take two glasses, right, where we will take the egg, like floating in the simple water and in the salty water, right? So same thing we are going to do, right? But I didn't have egg in my house, so I will do the experiment with the nimbu, right? Okay, I'll do this experiment with the nimbu, but before that, let us see if you're able to do this or not. Now see how beautifully this is happening. Can you see this here? Everybody, can you see this here? How beautifully this is happening? Because now it has enough ice. Not even one ice cube is there in the glass, right? So how beautifully it has picked up. Can you see? Right? Because now we had enough ice, right? I added like water in like right quantity. That is why it is able to hold it more efficiently, right? Can you see that, everybody? Yes. So that is depression in freezing point. This is called depression in freezing point, right? How beautifully it has folded all the ice cubes, right? So without even I'm dipping it, then again I'll have to dip it, then again I'll have to dip it so that ice melts, right? Even then it is not leaving these ice cubes, right? So that is the depression in the freezing point. So did you like this, right? Like this experiment or not? Even now, let us see, even now it is not leaving those ice cubes. Let us see now, is it leaving? No, it is like, okay, I'm totally in love with you. So this thread is actually stuck between these two. If you can see this thread is actually stuck between these ice cubes. Once these ice cubes starts melting because the temperature now has decreased. Understood? The freezing temperature melting, I'm saying the freezing temperature has decreased. That is the reason it will take more time to freeze, and that's why this thread got stuck in between the ice cubes. Okay? Yes, everybody? Yes, everybody? Now I need more jars. Now the first experiment that I showed you. This is the hot water, this is the cold water. In the hot water, still rate of reaction is more. In cold water, the rate of reaction is less. This you have also studied in lower classes like diffusion and all, right? Okay, so two experiments we have done, right? Two experiments we have done, right? Okay, now we will do the third experiment, right? For that, I'll just again come, right? But before this experiment, let's do some other experiment, right? Because for that, I'll need one lemon, right? I would rather firstly do lemon experiment than use the same lemon, right? In some other glass, right? So here, that is turmeric, vinegar, and washing soda. So again, I'll take one jar, right? I'll take one jar. So let us see if now the thread has left the ice cubes or not. Even now it has left. Now it has left, but no, 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 no. Now even now it is stuck. See, I'm doing nothing here, right? Okay. So that is when you do the experiment properly, then this will happen, right? Now, let us see. You have turmeric, right? Turmeric. You all can do this in your house also. These are the experiments, right? You know that these experiments are like, I think you must have seen these experiments, but what is the topic behind it, right? That is more important to know, right? So this is simple water I have added, right? Now what I am going to do, right? Now what I am going to do, I'm going to add this turmeric, right? Turmeric into the water, right? Now what we will see, that turmeric has made the water like a fruity color, as if you will think that, ma'am, this is maza or what, I want to drink it, but in reality this is haldi, right? Turmeric. Now this is the turmeric that you have, right? Now in this turmeric, if you add some washing soda, so this is the washing soda, like simple detergent in your house, right? That we use for for washing clothes, right? This is the simple detergents in your house, right? You can use any of it, right? So I'll just add this washing soda into it, right? I'll add this. I'm adding this. Can you see the color, how it is changing? Can you see? I don't even need to add more of it. It has already changed the color, right? Can you see how the color is changing? It is like a blood red color, right? Can you see that blood red color, right? Because whenever turmeric is a natural indicator, when it reacts with the, you have washing soda, for example, washing soda, it will turn it into, when it reacts with the base, it will turn itself into red color. That's why you have red color. Now, if you want to take out that red color, what you can do, right? What you can do, if you want to take that red color out, right? What you can do, I can just wash this here. In this, I will add some vinegar. You can see this is the vinegar, right? So any vinegar, any company, right? You can also use any acid here. You can use citric acid. You can use lemon also, right? Anything you can use, any acid, right? But because vinegar is in more like concentrated form, so that's why I have used it. Now, if I add, let's say, ma'am, can you please add one, can you dilute it? I'll add just few drops of water, right? And what you will see, everybody, now please focus here, right? So this is the indicator. This is the red color that you have. Now let's see what will happen. We are adding what? Vinegar into it. We are adding vinegar. Can you see at this point, the color has not changed to that much level, because it is an indicator. It will indicate only when all the acid and base has reacted. Right now, all the acid and base has not reacted. So it will show the full color of turmeric only when full acid and base has reacted. So I'll have to add more vinegar. If you see in labs, you do it with the help of burette, right? You add drop, you add, then you see that what is that point in which color will change, right? That is the point, right? So I'll add more of, this vinegar. Now can you see the solution? Even now you can see there is some foam over it, because the reaction has happened, right? Because the reaction has happened, that's why there is foam over it. Now, why this has happened? Because, can you tell me what reaction has happened here? Acid base neutralization reaction. Firstly, we added base, right? Then we added acid, right? They will neutralize, and turmeric will have its own original color, right? And you have the original color of turmeric back. This you will study in redox reactions, right? You will study hi-fi indicators, but I am showing you just simple indicator that we use in our daily life, that is turmeric, right? So this is based on which thing? Acid base indicator, right? This turmeric is a good acid base indicator, and it's a natural indicator. You can see this here. It is a full yellow color it has gained after this, right? Okay, so you want to drink this, isn't it? No, ma'am, we don't want to drink detergent plus haldi plus what I've added, vinegar. Yuck. So now let us see the next experiment here. Let us see the next experiment, that is bleaching agent plus color. Again, I'll take, or do you want, let's do the experiment on this one. Okay, let's do the experiment on this one only. Otherwise, I have red fruit color also. right? But let's try to do this. Let's see if Ala, this is a bleaching agent that you must have seen in your houses. Ala, this is Ala, which is a very good bleaching agent. Bleaching agent is the one which will take out the color from the things, right? So when you use a cloth, right, when you take out any cloth, you dip it into Ala, what will happen? This is a bleaching agent that color will fade away completely, right? Because that will take at least 24 hours to fade away the color of the clothes. So that's why I'm using a simple syrup here, right? So that I can show you in live what is happening here, right? So I'll just add the Ala into it, right? Let us see if it is disappearing, color is disappearing or not. In this case, the color is getting lighten up, right? I'll have to add more of it, right? Our glass jar is totally full, right? I'll have to add more of it, right? It is like color, you can see it is lightening. Color is lightening, okay? The intensity of the color has decreased, right? Now I'll have to split it into two, any other thing, so that I'm able to add more of Ala, okay? Sure. Now I can add more of Ala into it, right? Let's add more of Ala, right? Let's add more of Ala if you want to make this a completely colorless solution, right? So as you can see, the color is fading away. The color is completely fading away. When we will add more, it will fade away more, right? Because it has how many colors? We have added like turmeric. Firstly, it got converted into red color, right? And I did the experiment on that thing only. Now, I'll do the experiment on a fruit color. Okay, you can use anything, right? It's totally your wish what you want to use. I'll just take little bit amount of water, right? And I'll add any fruit color into it. I'll add. Now it looks like mango juice. Don't worry, I'll decrease. I'll try to make it like, oh my god. So this is the fruit color, right? That usually people use when you see, ma'am, green momos, ma'am, red momos, right? What they use, fruit color, okay? Fruit color is used in that. Even in cakes and all, you see, fruit color is used, right? Your ma'am also loves baking, right? That's why I know a little bit of these things as well, right? That color has decreased, right? Now, this is red color. Okay, this is red color. There are some like so much. It is looking like a cranberry juice, is it? Ma'am, it is looking like a cranberry juice, or what it is looking. So this is color now. Now my hands are full of colors. Now we will add Ala into it, right? Let's add Ala into it. Let's add Ala into it. Okay, let's add it. You will add, right? You will add. Now we will. Can you see this? Color it has to take away, right? Can you see? It has taken out the color, right, of that thing. It has reacted with the fruit color. Originally, right, if you add more of it, it will turn it into something blackish kind of thing, right? So can you see? It has taken out the color, right? So you use different colors, it will behave differently. If you see here, it has converted it into white color, right? It has converted this into this color, right? So that's how Ala will behave, right? That's how Ala will behave, right? So you take out any cloth also, you take out any cloth. Can you see this? It's completely, now I added little bit of this color into this color. That's why the color is changing, right? That's why the color is changing. So that's how it took out the color of turmeric. And here it completely converted this into a black color, right? Which was not the original color. It had taken out the red color. That means the color that you put into it will give you the original color of that, right? Either black or white. Usually it is white, right? So that is the action of bleaching agent, right? That is the action of bleaching agent, right? So bleaching agent is basically an oxidizing agent that you can see here. Bleaching agent is an oxidizing power, right? Because of its oxidizing power, right? Even if you can see my hair color, right? Original hair color was black, right? Then I don't know what get into me. Then I was like, I want to color my hair. Now I hate my hair, right? But firstly, they will bleach your natural color, right? Natural black color. Then they will put some new color. So that is bleaching agent for hairs. And it is even used to lighten up the skin color, right? So some people, right, what they do is they have like hairs on their face, right? Especially girls, right? What they do, they use bleaching. If you can see, there are so many bleaching creams, right? What they do, they will lighten up the black color of your hair, and that will be converted into the natural hair. So that is not completely converted into white color. That is rather converted into a very goldenish brownish color, right? That is the color of your skin, right? That's how bleaching agents work. They act as an oxidizing agent. They will oxidize something and they will take color out of that thing, right? Okay, is that clear to everybody or not? Yes. Chal. Now, definitely, beta, I'll definitely take the classes. Now, one of the best experiments, right, for today, that is lemon battery experiment. Let's do this. Okay, let's do this. Firstly, I'll just pick out the battery. Beta, this is multimeter. In this multimeter, you can see the voltage, current, right? Whatever you want to see. So here I'll fix the voltage. Currently it is at off. Okay. So I'll fix the voltage at 20, right? 20, so that I get the numbers in point something 1, 2, 3, 4. If I convert it into 2000 millivolts, then the number will be in thousands. Okay. So it's totally your choice how you want to see. I would want to see at 20. That is the standard way of seeing the uh, calculations. Now we have this lemon. Now we will make a cell from the lemon. This you can do at your home also if you have ammeter, right? So, bacha, if you will see this here, I'll just keep this here. I'll just keep this here, right? Okay, this is the lemon number 1, lemon number 2, lemon number 3. Okay. So, first thing is we will see that is in lemon you have citric acid, right? So citric acid, with citric acid we were able to see even this has turned completely white. Can you see bleaching agent work, right? This has turned completely white. Okay, bleaching agent definitely takes time to work. It needs some time. It can't directly just convert it. But now you can see that color of that haldi, the turmeric, it has completely vanished, right? So that has turned completely white, right? So that is the thing. Now let us see this thing here. Firstly, if you see this, right, that is electrochemistry, right? So now in this lemon, I have put one zinc nail, and I have put one copper wire into it. If you can see that, I have put what things here? I have put one zinc and copper wire. This red color, this is a plastic over it, right? Otherwise, it's a copper wire. Okay, this is zinc nail. Now, I'll try to see what is the voltage at this point. Can you see the voltage at this point is 0? Can you see the voltage at this point is 0? Right? The voltage is 0, isn't it? Now, I will see that if I put one end to the zinc, right? If I put one end to the zinc, let me see if you're able to see this or not. This is 3 lemon. If I put one end, if I touch one end with the zinc, and other end I'll touch with the copper wire, right? This is the copper wire, so I'll touch it here, right? Now, how do I show you that? Chalo, I'll just show you that like this. Okay, it's very difficult to show you that, right? So if you can see this here, this is zinc, this is copper, right? Okay. Doing this experiment in class is another task, right? Let me see what is the voltage that we are getting. Did you see any voltage? This is 0. This is 0.33 you got, isn't it? 0.33 you got. Chalo, how do I make it possible so that you are able to see this? Right? If I put, which thing should I put here? If I put, beta, I have only two hands now, what to do? Chalo, again, I'll do that, right? I don't know if you're able to see that or not, right? This is 0, okay? So I'll just keep it here only. That's the only choice that I have, right? I really needed someone, right, who can help me, but it's not possible at this point, right? So my my family is very camera conscious, so they will not come here to help me, right? So this is zinc, right? I'll just touch it on the zinc. See, till now it is 0. You can see it is 0. Now I'll just touch it on the zinc, right? I'll just touch it on the copper. What is the voltage that you can see here? What is the voltage? Can you see? What is the voltage that you saw? Huh. Voltage is 0.2, 0.30 something. Actually, the voltage will fluctuate, I'll tell you how it will fluctuate. So if you see, I'll just take out this here because, now it's like 2-3 hours it has been placed here only. I'll change its position, okay? I'll change the position of the nail here. That is the zinc nail. Because we need more of acid, more of citric acid. And I'll just change its position. I think this is fine only, right? Chal. Now I'll see what we can do here, right? Okay. Now, beta, till now I'm telling you only about one iron, okay? Only one circuit I'm telling you. Because this is the concept of physics as well that I'll teach you within a minute. That if you put it in series, what will happen? Now, again, you see this. This is 0 volt. This is 1. Oh, I'll put the zinc here. I'll just touch it with the zinc. And here I'll touch it with the copper. Right? What is the value you saw? What is the value? Has it changed? Let us see. Okay? Let us see. Let us see. What was the value now? Let us see that. Because I have just changed the position so that we can get a fresh. Now it was 0.46. Did you notice that? Because I see I have done the experiment like at 2 p.m. Till then, the zinc nail was dipped in the lemon only. So now, because environmental oxidation, right, the citric acid must not be there in the zinc, right? So that's why the voltage decreased, right? So now again I dipped it, right, with a new hole. So that's why you will see the voltage has increased. Okay, I'll again show you. This is point. Okay, this is zinc, and here it is. Uh, Here it is copper. Now, what is the voltage? Can you see this? Can you see this, everybody? What is the voltage? Let me just see if it is in the, because I am trying to see whether you are also able to see that or not. Yes, it is 0.42, right? Can you see? Now, was it minus 0.42? It was minus? Chal, let's change it. Let's change it. You have seen that E naught cell is equal to E naught cathode minus E naught anode. Let's do that. This is, again, this is 0, right? Now, I'll again put it 0. This is copper. Can you see now? It must be in positive, right? It must be in positive now. Is it? Let's see that. I'll also see that. This must be in positive now. Yes, it is positive of 0.42 because I have changed it. Okay. So when you do cathode, anode, you reverse it, then sign will definitely change. Oxidation, reduction, potential. Okay. Oxidation and reduction are opposite of each other. Okay. Understood? When I connect it oppositely, the sign will change because cathode is, sorry, inert reduction potential and oxidation potential are opposite of each other. Right? Okay. Now let's do this. Very good for knowledge. You're watching it. Very good. So now this was the, I was talking about only one cell. It had one copper wire and one zinc. Now let's talk about two things here, right? Two things means you have, let's connect it to two cells. This is first cell, this is the second cell. Okay. So this is one zinc and this is the copper that you have. Okay. Let us see what is the value that you can see. What is the value, students? It must be double. Let us see that. I'll also see that. It must be double. 1. And yes, it is not double, is it? Why it is not double? Let me just see that why it is not double. If it has not increased means there is some problem with this circuit only. Right? So I'll just see that. We need to put it into some new point. Right? Okay. Circuit you have to make new because that should double because you are adding something in series. This is actually a concept of physics. Okay. Aha. I hope so. I didn't break the. Can just do a hole here with this one, right, and put it there. Yes. Okay. Now, I'll see whether it is there or not. Okay. Let us see that. 0. First, I'll do myself only. This is zinc. This is copper. Why it is not so? I think because of this, is it? So many. You can see the lemon electron voltage you can generate by one cell, you can generate around 0.5, right? Let me just see that. All the engineers, right? You are going to do this. Okay, let us see now, right? It must increase, right? If it is not increased, that means there is some problem with the connection. Okay, with this and this, what it is showing? With this and this, it is showing it is fluctuating. Yeah. When I did it myself, then it was okay. It was doubling and tripling also. Now it is showing 0.4. I think because I am not stable now, because I am just carrying that multimeter also. I think because of that we are facing this problem, right? Let us see this here. This is the copper wire. This is the zinc. That means this particular circuit is not complete. Chalo, no issues. I just wanted to show you the physics concept also. Hush. Okay, let me try one more time. Let's see if it is doubling or not. This is zinc. This is the first cell, right? Let's see what it is showing. It is showing 0.31 now. 0.34 something. It is fluctuating only because we are not using a very strong electrolyte. We are using lemon that we eat, right? And here, if you have this particular thing here, right, this circuit also, right, with this circuit we are using this thing, right, it is 0.58 that has increased. 3 into 2 is what? It was 0.32. See, at this point it is, this is zinc, and this is the first cell. What it is showing, write it down in the chat box. What it is showing, write it down. Okay, let me see also what it is showing. It is showing you zinc and copper. It is showing you 0.34. Okay, let's keep it to 0.34. Now with the second one, it is showing zinc. This is copper. This is the copper here. Let's see what it is showing. Okay, let's see. This is zinc and this is the copper. It is showing 0.46 something. Okay. Otherwise, one lemon was giving 0.46. I think now the lemon is old. Like, it has been there outside and it's so hot here. That's why the juice is not there maybe, right? The electrolyte is not that strong, right? Now the last one is this one. Okay. This is this one and you see this one, right? Now it will increase to the triple. This is 0. This is the third one. Can you see it is into 3 times, right? When I did it in the morning, for one cell it was coming out to be 0.5. For 2 cells it was coming out to be 1. And for 3 cells it was coming out to be 1.5. Now it has changed. Now it is different, right? Because time has passed. So it is one cell it is coming out to be 0.3. 2 cell I think it is coming out to be 0.5 or 6, and for 3 cell, that is this one, it is coming out to be 0.7, right? Can you see this, right? Did you observe this, students? Did you observe this, right? Okay. Lime water and salt water. That we can do, but for that we need a beaker. I just wanted to make a cell for you. Don't worry. When we will do electrochemistry, I'll do the experiments with NaCl, water, and all these things we will do. Right? This is something new that I saw on like so many experiments based on this. But I also tried. I had a small bulb. Right? Bulb means those bulbs that is used in the electronics. Right? Those bulbs I'm talking about, that is only 5-volt bulb. Now I use that bulb, right, for 1, 2 nimbus, 3 nimbus, 4 nimbus. I was not able to turn it on. So it is said that, okay, you require, if for 1 it is giving, ideally when you have a fresh lemon, ideally it is giving you 0.5. So for 5-volt, you need to have 10 lemons in series only, then you will get like 5 volts, right? Then only you can light up a bulb of 5-volt. Right? Otherwise, with 1 lemon, it's not possible. It doesn't have that much voltage. The voltage is very less. As you can see it here only, right? The voltage is very, very less, right? You can see this with 3 bulbs also. With 3 bulbs, I am saying with 3 lemons also, it is very less, right? Okay. So with 3 also it is 0.7. Ideally it should be 1.5, but obviously this is like, I didn't wanted to waste a lot of nimbus, right? Because nimbu is very expensive right now. So what I'll do, I'll connect 10 nimbus for you, right? But yeah, frankly, I didn't have that many nimbus in my house only. I had only 4 nimbus. So that I tried. Okay. So done. Now we will do one more experiment. For that, what I'll do, I'll use this only. Okay? I'll use this because I don't have any other glass now. So, and I will use this only. By that time, can we see what the bleaching agent has done? Can we see what the bleaching agent has done? See, bleaching agent is doing its reaction. This is so completely white. This still it is converting it into transparent. It is still doing that. It is still converting it into transparent. This is completely white, right? This is completely white. So that was bleaching agent. Isn't it amazing, right? So last one is this topic was electrochemistry. Now the last one that I told you here only, right? That is egg I didn't have at my home, so I have Nimbu. So I'll take out one Nimbu from here only, right? And I'll dissolve it in some. Now the thread is not after ice cubes, right? So I'll drop it here only, right? So So what we will do? Full kitchen I have in my studio right now. If you see my studio at this point, you will see I have full kitchen, right? So this is, I think, salt is already dipped here. So I will not waste more of salt here, right? Salt is already dipped here, right? What I can do is I can use some normal water. For that, what we can do, we needed to have one more, you know. Chalo. This I can just, I'll just keep this aside. I'll just throw this, right? You know that it has converted, bleaching agent has converted into transparent water, right? This is that red fruit color only, that is transparent now, right? You can see that. Bleaching agent is working, but very slowly because fruit color is very dense. It's very high color it has. So for that, it has to work a lot, right? So now, right, I'll just throw this, I've just thrown it out, right? Now I'll take simple glass, right, simple water, because right now you have nothing here. I'll just take it, right? I'll add more of water into it, right? I'll add more of water into it. Chal, just add it. Okay. Now, if you see, this is Nimbu, right? If I drop it here, right? Is it floating? Is it floating, guys? Is it floating? Na, 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 na. Right? Now, I'll just take that Nimbu out, right? For that, definitely we need a spoon, right? I'll just take that Nimbu out, right? And now, I will add some more salt into this. I'll add some more salt into this, right? I'll add some more salt into this, right? That is a non-volatile solute I'm adding into it, right? Now, when you add salt, right? Salt into the water, right? What you will see here, when you try to float it, it is not floating. So when you try to dip it, it is float. It is not actually dipping. It is floating. Can you see that? It is floating. But if I keep the same Nimbu, same lemon here, right, it will dip, right? It will dip. You can also do the same thing like this. Okay. So you can also do this thing here. When you like dip it here, right? When you dip it here, it will, this is a salty water, this is a normal water. In the salty water, the lemon will float, and in the normal water, it will dip, right? So can you tell me the reason behind this? Can you tell me the reason behind this? Why this is happening? Why this is happening? So reason is, when you add a non-volatile solute, the density of this has increased. The liquid density has increased. And that is the reason, right? Colligative property, that means when you add a non-volatile solute, colligative property that is dependent on the mass, right? That has changed. That is why it is floating around. So this is based on the colligative property, right? Mostly it is, you can also apply Archimedes principle, all those things that you have studied in physics, right? But according to, like in chemistry portion, what you have here is colligative property, because the density has increased. That's why it has started floating here, right? Okay. Water will float after sometimes. Chalo. After sometimes, why it will float, right? After sometimes, no, right? Because normal water, if you increase the density, right, by any matter, right, by increasing the pressure, anything you add here, by if you increase the density, only then it will float, right? And if you increase the temperature, then also, if you are talking about after sometimes, it will a little bit heat up and then it will float, that's a different concept. Okay, right? So guys, that's it for today's experiments. Now let me know, how did you like all the experiments? Let me just take out the Nimbu, because we need to do other experiments also, we will do with lemon, right? So at this point, my studio is filled with so many kitchen things, right? So how did you like it? Did you like this session, everybody? Now, yes, I think now we don't need that table, right? So everybody, now we will do some riddles or puzzles here, right? Let us do that. Let us do that. So first is, right, let us see if you're able to, as I told you, we will have some experiments and we will do fun with chemistry. So here it is, the riddle of the twin identity. I can shine like a diamond or leave a mark like a pencil. What I become depends on how atoms bond. Who am I? Everybody, who am I? Let us see who is able to answer this. Like the one which can leave a mark like a pencil and shine like a diamond. What is that element that forms diamond also, that forms pencil also? That element is carbon in its graphite form. It is used as pencil, right? In its diamond form, it is used as diamond, right? So two things it has. So answer is carbon, right? So next is add me to water and I go boom, right? That means in water it will react very aggressively, but bind me with chlorine and I land in your food. So what is that? When you bind something with chlorine, it will be used in your food, right? And when you add it in water, yes. And when you add it in water, it will react very aggressively. What is that element? Yes, that element is sodium. Very good, Kevin. Very good. Right? That element is sodium. Because with NaCl, it is in the food that we use. NaCl, salt. And sodium reacts very aggressively with water. That's why we keep it in kerosene oil. Right? So, let us see the third one. The noble gas, the noble who don't mingle. I am full of, this is under noble gas. I am full of mystery, stable, unreactive, don't bond with anyone. Still, I light up signs in red. Who am I? So, I have full of myself. I'm full of myself. I'm stable. I'm not reactive. It's like I'm single. I don't want to mingle, right? Don't bond with anyone, right? I'm happy in my own zone. Still, I light up signs in red, right? What you have seen it at night. What are these things that you see? What are these things that you see at night, right? You will see on the roads also, right? Yes. So that is neon, right? Neon has that color that will light up the signs, right? So in signs, you will see, in traffic signs, you will see neon there, right? Because that is very, like we can see this from the very far away also, right? Okay. Next, let us see. Next one, let us see the light metal mystery. I am a metal, but I am a liquid at room temperature. Touch me, you might need a thermometer. Who am I? Touch me, you might need a thermometer. So basically, it is a metal that is liquid. So do you know what is the metal that is liquid at room temperature? What is that metal that is liquid at room temperature? What is that metal? That metal we all know. What is that metal? That is mercury, right? Is it? That is mercury. Mercury is silverish grayish color. It is liquid at room temperature. It's not good. Means if you touch it, like if you don't have any wounds and you touch it, I would not recommend it. But still, if you touch it, it's fine. But if you have any wounds, if it get into your system, then it is very, very harmful, right? So anyway, it should not get into your system, right? So now I will give you 2, 3 for your home, right? Achha, ठीक है. So 2 we have for your home. The melty metal. I am a solid at room temperature, but a little body heat is enough to make me flow. Who am I? Melty metal. Who is solid at room temperature, right? But it will melt as soon as you give it little bit heat. That means even in your palms, it might melt. Even in your palms, it might melt. Anything. That is gallium, right? Gallium is that metal which will melt even in your palms. Now, last 2 is for your homework, right? That is the purple disappearing act, right? This is for your homework. Let me see who is able to tell me that. I am a purple crystal that disappears into thin air when heated. No liquid in between. Who am I? Right? This one. And second puzzle is the green aging artist. I am used to shine copper red. Now I wear a green coat instead. Time changed me. Who am I? That means it is something related to corrosion, right? So you have to tell me that what is this 7th one and what is this 6th one. 6th and 7th you have to tell me in the comment section. I'll definitely wait for your comments in the comment section. Yes, students, so that was it for today. So today was a fun session of JEE, right? We did some experiments here. We did some random puzzles so that we can understand chemistry, not only in the theoretical purpose, also in a fun way what chemistry is like. Okay, so it's a very, very interesting subject. Yes, and we will get to more detail of this subject. And this was a fun session, right? Fun means relaxing session. When you learn something also, your knowledge also increases and you learn the practical applications of chemistry as well, right? So that's it for today, students, and this is our official Telegram channel, and this is my official Telegram channel. You can connect me here, and this is my Insta ID where you can connect to me, you can talk to me, @Diksha. That is my Insta handle. You can always talk to me on this Insta handle, and I want you guys to comment down that puzzle, that riddle that I gave you, 6th and 7th. I'll again show you that. This is the purple disappearing act, right? That means someone which is purple crystal, right? And here it is corrosion, which is copper red, then it turned into green, right? I think these two you can easily answer, right? And students, if you are preparing for 2026 or 27 or 20, like 27 only, right? So based on that, we have different things for you. If you are preparing for 2026, then students, we have Sigma JEE batch for you. You can click on here. That is the 12th and dropper batch, right? You are preparing for JEE 2026. You can just purchase this batch. Why? Because we are giving you the live classes here. Not only live classes, we are providing you notes. We are providing you the doubt sessions are being solved in the class itself, right? And then even after the class, you will be able to, like, you can replay it and your doubts will be solved even after the class in between the replay version, right? And then it is right now it is discounted price. Yesterday it was 4,999. Now it has discounted for 1-2 days for 3,999 here. Those students who want to save their money, definitely go for today only. And the batch has already started. After every 15 days, you will get the mock test also based on what we have covered in last 15 days. And after that, if you want any test series, ma'am, I want test series, ma'am, I want to do on my own also, I want to take tests, then you will get 40 part and full syllabus tests also. If you want to do more practice, which is definitely needed, we have our own Tattva modules for you, in which previous year questions, level 1 to advanced level of questions are there in that Tattva books, right? Soft copy or hard copy, both can be provided to you depending upon what you choose, right? So all these things are there. And in the class also, we give our students that, okay, these are the tattva questions that you must do. And if you want more practice, then we have given you different books. You can generate your own DPPs also based on the different collection of books that we have in the batch, right? So all these things we are providing you. It will be really great if I see all of you in the batch, because don't waste your 1 year. There is no benefit of giving lakhs and lakhs on donation. Instead, get a good seat, and instead of spending on those donations, spend on what is needed. Spend in your future, invest in your future. That will be more beneficial for you, right? Okay. So yes, students, that's it for today. So I'll see you all tomorrow, and I'll wait for your comments in the comment section. What is that 6th and 7th puzzle? Till then, bye bye, take care, bye bye.